I'm waiting on the phone to be put away. And I'm recording. You're lucky I'm not calling you by your name. Stop it.
Give me a shout out.
Stop it. All right, Ruby, let's read number 2 in part A, please.
Given the function f of x equals x squared plus 1, estimate the area bounded by the graph of the current on the x-axis on 0 to 2 by using a left Riemann sum with n equals 4 equals 7 sub-intervals. Is this an underestimate or an overestimate?
So I'm going to circle left with the color that I'm going to coordinate. We're looking at 4 equal subintervals. So if we kind of look at the chart already, is this somewhat laid out for us on the graph? 4 equal subintervals. We could say 1, 2, 3, 4. Yeah? So what number has to go in between each? Half, and then 1.5. Now notice the t-chart is not given to us, which is fine because we have our function. So let's go ahead and make our t-chart right here. Here's our x and f of x. And we know we have to start at 0 and jump to 0.5 to 1, 1.5, and then our 2. And let's see if that's actually going to make our 4 subintervals. So loop 1, 2, 3, and 4. And it'll always be evenly distributed that way. So on my calculator, let's assume I don't even know how to compute. I want you to type in the function given. And then on our window, I want to make sure I start at 0. And it says changing table by 1 goes to 0.5. Because I'm going to 0.5 each time. Thank you. And then when I go to my table, it's going to start at 0 and give me all the values. So 0 to 1, 0.5 to 1.25, 1 to 2, 1.5 to 3.25, and 2 to 5. The function given right there, x squared plus 1. Okay, I'm going to wait 10 seconds for those of you guys catching up. And if you're done, go ahead and plot your points. 0, 1, 0.5, and 1.25 is approximated. Was it 1, 1 or 1, 2? 1, 2. Oh, goodness. And 1.5 to 3.25 and 2 to 5. And we'll connect the graph in a little bit. In the meantime, let's box this off using left Riemann sum. So here's my left, and here's my left, and keep going. And I'm going to color this one yellow. It's not too pretty. That's okay. So the ones that we're going to multiply, or not multiply, to write out, we have, that's my left. Oh, it looks like they're all my left, right? Is everyone okay with why I circled all of them? Within this zone, 1 is left. Within that zone is 1.25, and so on. Or if you want to think of it as 1, 1.25, and so on, as length times the width, that works. Now for this one, they're each jumping by how many of the value of the x? Each time, 0.5. Then we have 1.25 times 0.5, and 2 times 0.5, 3.25 times 0.5. Is everyone okay with what I came up with? We got length times a width, 4 times. Let's go ahead and compute this on the calculator, and it's going to give you a clean decimal. Something in the 3s. Not 25, but 3 point. I guess we don't want to use a calculator on the quiz, right?
Yeah, I said 5.7.
5.7? 7.5.
That's
That's okay. And let's actually go ahead and connect a curve from the left Riemann sum. Is this over or under estimate from the curve? Under. And on this one, we're not going to say because the speed is increasing because nothing told me about the speed. We know just about the f of x. So let's write out because f of x is increasing. And visually, it makes sense. It is under the curve. And then let's do the right Riemann sum. If you're being consistent with mine, I'm going to use pink. Okay, so let's redraw. From the first subinterval, here's my right, there's my right, and again, we're only approximating today. And there's my right. And I guess you can make your little diagonal shaded piece. So if I do length times the width, or everything on the right, that's going to give us 1.25 times 0.5 plus 2 times 0.5 plus 3.25 times 0.5, and lastly 5 times 0.5. Let's type that in. And it's got to be greater than the left Riemann sum. Pretty close to 6s. How many?
I'm just a little confused.
Yes.
At the last one.
The last one.
Yeah. Isn't the very last one in the question? It said 3.25 times 0.5. Wouldn't it be like 1.5?
No, it would not be, because what's the difference between 1 to 1.5? It's the difference of each interval. Okay? So it's going to be 5 point how many? 7.5. And we know clearly this is under or over. Over, because our f of x is increasing. So can y'all kind of imagine if the f of x is decreasing, it's going to be the other way around? Okay? I will show you guys that visually in 2 days. Okay? All right, part C. Ellen, let's read. So we are looking at trapezoidal. Let's go ahead and box that piece. And just for the teaching purpose, go ahead and replot your order pairs. So we got 1 and 2. I guess you can use the same one above, but it's going to get kind of messy. Make your curve. And I'm going to use one of them that's kind of exaggerated. And whichever you pick doesn't really matter, but I think I want to pick the second subinterval. Connect these two. Just by looking at this, when I shade in the trapezoid, is it under or over? It is very slightly how many? Not how many. Is it under or over? Over. So let's go ahead and write in the following. The first one, our base is 1 point, or not 1. How many was that one? Is that 1.25? And then the second one was 2 point how many? Well, exactly 2. And actually, let's not do that. Since I know my left and right, can I take these two and just find the average? Yeah, let's do that instead. That would have been very silly on my end. Oh, my fan is not happy. So we had 3.75. Ooh. So if you want to write the formula again, go for it. Left Riemann sum plus the right Riemann sum divided by 2. It's going to give us the trapezoid. So we have 3.75 plus 5.75 divided by 2. And that's 4.75. And we know just by the picture that I can exaggerate it here. It is over. And here's a reasoning that's different. This right here is called concave up. And that's the reason why it is over. If it's concave down, it'll be vice versa. And I think visually it makes sense. Okay, on the bottom, which Riemann sum are we looking at on the bottom? Midpoint. And since I didn't give you a table, I think it's fair to go ahead and graph this. So 1, 0, 1, 1.25, 2, 3.25, and 5.
Wait, is it supposed to be different since there's like 2 sub?
Yeah. For 2 subinterval, I don't even care about in between. And the reason it's making it into 2 subinterval is to force some number in the middle. So just by looking at this, let's see where our graph is going to look like. Here's my left, middle, and right, and it says midpoint. Let's go to the middle and make our rectangle. My second subinterval is at 1, 2, not 1, left, middle, and right. We want the middle. Wish that was straighter, but that's okay. And shade it in however you want. And go ahead and connect, if you want to, the curve that we made on the previous one. Ew. Not so pretty. All right, so if I do my length times the width, the first one is how high? 1.25. Now this time, what is the difference between the beginning and the end? It's not 0.5 anymore, but 1. So length times the width is 1.25 times 1. Second one, how high is it? 3.25. And then how wide is it? 1 again for that subinterval. The total is 2 though. And that is 4.5. And again, if you notice a trapezoid and midpoint, they're pretty close to each other. Everyone good with this? So I think visually it's going to tell you if it's under or over midpoint. It's not going to be very possible. Now, on the next one, your calculator will be crucial until we get to this lesson next week. There's actually a way to actually derive this or find the area under the curve to find the exact value. So last year we did derivatives, right? So this semester we're doing antiderivative. You're like, what? And now we'll get to next week. But for today, let's cheat off the calculator. Sophia, let's reparty. This symbol right here, it's called the integral. It's also called the integration. Basically, it's to find the area under any curve, no matter what. But then it says to use a calculator using the F3 menu. I'm not using TI-89. Let's use TI-84, and I'm going to give you a trick on this one. And if you know 2 buttons, you're good to go, all right? So let's write something on the side. We're going to write out math and 9. And let's bubble that off. Very important. Do we all know where the math button is? Underneath the what?
Alpha.
Alpha, good. You can scroll down to 9 or click on 9, and it'll populate the skeleton model of the integral. It wouldn't copy exactly as I see. The bottom number is 0, top number is 2, the function inside the parentheses, and it's always in respect to dx. And this is going to tell us the exact value of the area under the curve that we were approximating so far. Is everyone there? Press enter. So if I want this in 3 decimal places, it's 4.667. So let's compare. Is 4.667 closer to my trapezoid or the midpoint? For this one, it happened to be trapezoid. Yeah. It doesn't mean it's always trapezoid. It really depends on the problem. Okay? All right, my last one. And by the way, on number 6, go ahead and write your name on here so you know that part is the homework. When I'm checking it, your name is not on there. I'm going to assume something else. And the homework is page 6, 7, 8, 9. And yes, that's already listed on Google Classroom. So let's finish the last problem. All right, Gianta, let's read number 3, the last one.
In order to determine the average temperature for a day, a meteorologist decides to record the temperature 8 times during the day by the data.
Hey, we're reading. Can you start over?
In order to determine the average temperature for a day, a meteorologist decides to record the temperature 8 times during the day as indicated by the data. Use a Riemann sum with the interval between to estimate the average temperature.
So let's go ahead and box average temperature of the day. So let's say I don't sleep and I stay up literally a whole day. How many hours should I be dividing this by? So we should be dividing by 24. So what our anticipation is, when I find the how many hours in each interval, it should be 24. Now, so far, all the intervals were evenly distributed, correct? There were 4, there were 0.2, there were 1. Is it evenly distributed in this case? No, it's not. So let's go ahead and find out how many in each part. This one is 5 hours. The second part is 2 hours, 2, 4, 3, 3, 2, and 3. So unlike previously, we'll multiply by the same number at the second portion. This one, we're multiplying by different numbers. Okay? So bear with me on this one. It's going to be pretty long. The first one is going to tell us it's going to be 42 degrees for how many hours? 5 hours. And then it's going to be 57 degrees for how many hours? And then 72 degrees for 2 hours. And then we got 84 for 4 hours, 89 for 3 hours, 75 for 3 hours. I might get there. 66 for 2 hours. And lastly, 52 for 3 hours. Type that in. And your number should be in the thousands. $1,584. But what do I need to know if it's the average temperature throughout the whole day? Divided by 24. And that's going to give us how many degrees? 66. Boom.